Good afternoon. This is the second half of the walkthrough for the past paper that I gave you for your end of year exam. So this will help you to be able to go through your work. So we did questions 1 to 4 this morning. So if we look at questions 1 to 4, we've done that. Yeah, that's on my previous YouTube video, or downloadable from WeTransfer, as long as you do it within the next few days. So looking at question 5 onto electricity, it says state Kirchhoff's second law. Again, this is a statement, so this is something you learn. You learn this off by heart, and it's 2 really easy marks, and it's basically the sum of the EMFs, or electromotive forces. That's the voltage across batteries, neglecting their internal resistance. The sum of EMFs in a closed loop is equal to, oops, not equal, not equate, equal to the sum of potential differences. And you can say PD if you wish to, sum of potential differences around that loop. Okay, and that is good enough to actually get the marks that you actually need. Next question is looking at a circuit. Now I've not counted this one in your final exam simply because this didn't print out very well. So I've sort of gone back, looked at it, and this is roughly what it looked like in the real exam. So you've got a closed loop circuit here. You've got your voltmeter here. You've got your R here, your variable resistor, and it's adjusted until the reading on the voltmeter reads 0. Okay, so you've got 2 batteries connected with electromotive force of 6 volts. And you've got 3 resistors in series, but actually this is actually 2 closed loops. But you've got 1 closed loop here, because the voltmeter makes part of a closed loop, and 1 closed loop here, the voltmeter makes part of a closed loop. Potential difference across that voltmeter is 0. Okay, so the voltmeter reading is actually 0 here. This must mean that in this closed loop, if the voltage between here and here is 0, then this EMF must be the same as the the potential difference across that resistor. So if we use Kirchhoff's second law, we know that the total voltage is going to be 0, okay, because that's the total EMF across here, is equal to the 6 volts minus the 4.0 volts multiplied by I. Okay, now the reason why it's opposite is if that's plus 6 volts, that's going to be minus 6 volts, so that the potential difference reading here, with voltmeter reading here, sorry, is 0. So as we move on, we can then say, okay, well, I is going to be 6/4. Okay, I'm not too bothered about the direction, to be honest with you. So that 6/4 is 3/2, which is 1.5 amps. That's easy. It's just a question of recognizing that that here is a closed loop where that voltage reading, that potential difference reading there is 0. Okay, so there's no current flowing through there. It's a voltmeter anyway. Should have an infinite impedance, but the potential difference across there is 0. The current is 0, so it's a closed loop. It then says you have to calculate the resistance R. So we're going to continue using the loop law. Well, the sum of the EMFs, well, this time we're going to use the outer loop, this outer loop here. In this outer loop, you've got this EMF here, and this battery is actually pointing the same way. It's actually reinforcing. So the total EMF is 6 plus 6. So the total EMF is the sum of the current times resistances for the whole circuit, for the outer loop. So the sum of the EMFs is 6 plus 6. And the total, well, if we think about it, it's I times 4 times I times plus I times R plus I times 1.5. Now the current here is going to be the same because there's no current flowing down here, so the current throughout the whole circuit's the same. So I can take that out. I can take that outside the expression. I can say the current I, which is 1.5 amps, multiplied by 4 plus 1.5 plus R. Okay. So that would be 12 equals 1.5 times 5.5, sorry, times 5.5 plus 1.5R. And you just solve that for R. You just make R the subject. There are other ways of doing it. Divide the 6.6 by 1.5, and then you subtract the 4, subtract the 1.5. It's another way to do it. Absolutely fine. We end up with the factor that R is going to be equal to 12 over 1.5 minus 4 minus 1.5. Okay, and then that leaves you with 2.5 ohms. Okay, as a resistance, it comes out. So moving on, we've got resistors X and Y are made from the same material. The diameter of wire X is twice the diameter of wire Y. Determine the average drift speed of the free electrons in X over Y. Now, you do not express this as a ratio or fraction. A lot of answers I've received were people expressing this as a ratio or expressing it as a fraction. It's not really, although it says determine the ratio, you should really be using, pardon me, you really should be using decimals. So what we do is we basically take this idea, the average drift speed. So we know that the drift velocity is given by it's given by that formula. Well, that's the drift speed. So the drift speed is the current divided by NAQ. Okay. Now, all you're doing is you're trying to work it out for X and Y. So X is that, and the only thing that's different here is the cross-sectional area. So if I plug that into here, we have the average drift speed velocity of the electrons in X, so that's going to be I over NAX times Q divided by the same current because they're in series, divided by NAY times Q. Okay, so we then have to just work it out. Okay, well, we could tidy this up quite happily. So what we've got is I, and this bit here goes up to the top, NAYQ over I, and this goes underneath, NAXQ. The I's cancel, the N's cancel, the Q's cancel, because that's just the charging the electron. We end up with AY over AX. So it's actually the ratio of the two areas. It tells you the diameter of wire X is twice the diameter of Y. So the diameter of X equals 2 times the diameter of Y, both of which are proportional, both of which when you square them are proportional to their areas. Okay, so if the diameter of X is twice the diameter of Y, then it's 4 times the area. So if it's 4 times the area, that's going to be a quarter. So it's a ratio of 1 to 4, otherwise known as 0.25. That's the correct expression for it. Okay, that's how you work that out. So the value of resistance R is now increased. State explain the effect on the resistance R and the power transformed by each of the batteries. So you've got to think about it very, very carefully. Well, actually, it's a relatively simple question. If we increase R, then it makes sense that the total resistance of the circuit will increase. Okay, let's keep it simple for a second. If the total resistance of the circuit increases, the current will decrease because the EMF is going to be the same. Oops, spelled correctly. Okay, so if you've got the current decreasing, therefore, since the power is proportional to I squared, power will decrease. And that's your answer. Easy as that, okay? It's actually a much easier question than it looks. Little exam tip, do have a look at the last couple of questions on each exam question, simply because sometimes it can be pretty unrelated to the question, and it can usually be quite a simple answer. So, last but not least, and then we'll wrap this up. You got a sample of radioactive isotope emits beta minus radiation. So you need to be on nuclear physics sort of mode, if you like. It then to state the change, if any, to the number of neutrons in the nucleus of the sample that emits a beta minus. Well, if you're emitting a beta minus, you know for beta minus, you have a neutron in the nucleus, decays to a proton plus a beta minus plus an anti-electron neutrino. So the number of neutrons, that one neutron will become a proton. So the number of neutrons will decrease by 1. Because that neutron has become a proton. Then so the number of beta minus particles passing a fixed point in a beam in a time of 2 minutes is 9.8 times 10 to the power of 10. Calculate the current produced by the beta minus particles. So the current is simply the charge over the time taken. So the charge is this number of particles multiplied by the charge of each beta particle. Well, it's an electron. So that's the elemental charge from your formula sheet. It's 1.6 times 10 to the power of minus 19 coulombs divided by, and it's 2 minutes, that's 120 seconds. That's it. It's as easy as that. What an easy 3 marks. It's incredibly easy. And you end up with 1.3 times 10 to the power of minus 10 amps. But it wants it in picoamps. Well, if we think about it, that old mnemonic, terrible. I know it's a little bit sexist, but it's a good way of remembering it. Terrible girls make kind men microwave nasty pizzas. Okay. The cutoff here for a simple unit is in the middle. So that would be 3, 6, 9, 12, minus 3, minus 6, minus 9, minus 12. So 1 picoamp is exactly the same thing as 10 to the power minus 12 amps. So then you've got to work that out in picoamps. So you just got to literally divide that by that. Okay, and that comes out to be 130. Job is easy. That's a very easy question for 3 marks. Then to suggest why the beta particles are emitted with a range of kinetic energy. Remember that this was the part of the evidence for the existence of neutrinos. So that's the first thing we could say is we know that an antineutrino is also produced. And that's the stupid simple bit that a lot of people miss out when they're answering this question, simply because they jump straight to sort of the more complex part of the answer, which is the idea that the neutrinos or the antineutrinos share some of the total energy transferred. or just say they share some of the energy, that's fine. Okay, and they also share some of the momentum, of course. And that is the end of that paper. So what's your next task? Well, your next task is to go through parts 1 and part 2 on YouTube. Go through your paper that I've sent back to you if you've done it. If you haven't done it, you need to print out the paper that you've got and make sure that you've given it a good try. If you're completely stuck, print out the paper that I've given you, and you can then follow through what I do so that you get some kind of experience as to how to answer these questions. Other than that, I will see you all on Friday.